Welcome to the second video on 5.7 graphing. Quickly here, finding the graph of the original function if you are given the first derivative of function. Because oftentimes you are given the first derivative, so where do we start? Okay, just from last video here, first of all, we want to spot the roots because these roots either become a maximum, a minimum, or, sorry, not become, but they were maximum, minimum, or they were a stationary inflection point in the original graph. And then after you've done the roots, then let's look at the minimum and maximum points of your first derivative graph. So everything on this side here is the first derivative graph. Everything on your right-hand side here is the original function. If there's a minimum or maximum, then you're going to find inflection points or points of inflection that weren't already stationary points of inflection in the first one. Next, you know that if your first derivative graph is positive, it means you've got a positive slope in the original graph. And vice versa, if you have a negative first derivative graph, it means you had a negative slope in the original graph. We're just going to do one more example over here. Sketch the graphs if given the first derivative below. Okay, so that's the first derivative graph. Just read that carefully here. And we're just going to sketch the original. Okay, so we are going to follow those steps here. We're going to spot the roots. Okay, spot the roots. Here's my first root. Here's my second root. And I'm just going to take a ruler here so I can overlap those. And you'll see you actually have a lot of freedom. We're going to interpret this drawing together here, and you'll see, oh, I don't actually know what exactly the original graph looks like because this question doesn't give you any specific points. So I know the maximum exists somewhere along this line, and I know the minimum exists somewhere along this line. And next, let's look at our curve, okay? The curve here has a minimum right here. Okay, so I know that's a point of inflection. And again, all that tells me is the point of inflection is when x value is equal to somewhere along this line. A common mistake is to try to draw your line all along here. Okay, it doesn't mean the curve looks like that. Let's actually look at the slope. I see that my slope graph tells me the original function should be positive here, so a positive slope. And over here, that's a positive slope. And right along this middle area, I'm going to have a negative slope. It doesn't mean that the original y value is negative here or positive here. It just means the slope itself is positive or negative, okay? So if the slope here is positive, somehow my slope has to look like this. Slope over here is negative, so this is decreasing all along here. And slope over here is positive. So here's one way I could draw this. I could draw it with, as long as my maximum is here, is along here, and my minimum is somewhere over here, right? I could have something like this. Okay, does it follow all the rules we've looked at? Yeah, okay. Here's my maximum, that works. Here's my minimum. Oh, sorry, that's not my minimum. Let me just draw that again. Okay, that's better. Visually, it's a little bit off here, but let's just say that's my maximum and my minimum. And my point of inflection, yeah, it looks about right, okay? Point of inflection being right in the middle here. So that could be my graph. But again, we don't know exactly what the points are, so my graph could also look like this. And that still follows the rule. This is my point of inflection. Here is my maximum. Here is my minimum. And notice this time, all of these points here are when the output is negative. All of these points here are when the output is positive. We actually can't predict whether the output was negative or positive unless we know the actual value. So at least we know what the x value is at the minimum point and the maximum point that could help, or the POI, okay? Or we have an equation of the line, or we have the f of x first derivatives equation. Okay, so if the question gives you more information, which actually usually it does, then you can get a more accurate graph. If it doesn't, that's what we have here. So we are correct in assuming that this graph can actually move up and down. We can translate it upwards and downwards and still have it be correct as long as the maximum and minimum and POI points line up with the original graph.